Hi, welcome to Dr. Raz, the Baking Chemist. So today's question is a physical chemistry, a maths of substance type question. It's a student request. It's an AS level question. And it's one of those questions where they just give you numbers, lots of figures, numbers, and then they pounce a question on you. And you're thinking, you what? Let's find out. Iso-octane is an important component of petrol used in cars. Yeah, again, iso-octane, do you know anything about it? Do I know anything about it? Do I need to know anything about it? Don't let it put you off. It's an important component of petrol used in cars. When iso-octane is burnt, the enthalpy change is minus 47.8 kilojoules per gram. Iso-octane is a liquid at room temperature. I wonder why they're giving you that. Anyway, at room temperature with a density, density of 0.692 grams per centimeter cubed. Calculate the heat energy released in kilojoules when 1 decimeters cubed of iso-octane burns. So the question is, we need to calculate the heat energy released in kilojoules when 1 decimeters cubed of iso-octane burns in excess oxygen. Give your answer to the appropriate number of significant figures, and it's only 2 marks. Yeah, so it can't be that difficult. So here, they just seem to have given me sort of details about iso-octane, and then they just said like calculate heat energy. So the question is, why have they given you density? Why have they given you enthalpy change? Now, when I look at a question like that, the first thing that I do is I start looking at the units, because units sometimes gives me clues. Yeah, so that's kilojoules per gram, that's grams per centimeters cubed, and this is decimeters cubed. Now immediately I'm thinking, okay, let's write this down. So let's look at this enthalpy change, right? Enthalpy change. Now often, you look at this enthalpy change, but people don't understand, students don't understand what it actually means. Now let's try and explain it, right? So kilojoules per gram. So that means every 1 gram of iso-octane, I'm not going to keep writing its name, gives you 47.8 kilojoules. Right? So 1 gram of it gives you 47.8 kilojoules. Now, the density they've given you, right? Okay, but the first thing is 1 gram. And then they're saying, forget the density for the time being, then they're saying when 1 decimeters cubed is burnt. So when 1 decimeters cubed is burnt, how much energy does it give you in kilojoules? So now, when 1 decimeters cubed is burnt, what's that in grams? I don't know. Yeah, I know for grams, 1 gram gives you that much, but what is 1 decimeters cubed? And this is where density comes in. So for example, you know that density, looking at the density, it tells you that 1 centimeters cubed is equal to 0.692 grams. So 1 centimeters cubed is 0.692 grams. And if I know that 1 decimeters cubed is burnt, then can you see now, I can use that to figure out how many grams that is. What is 1 decimeters cubed in terms of grams? And you should know this, 1,000 centimeters cubed is equal to 1 decimeters cubed. So I need to take that 692 and multiply it by 1,000, because I know that 1,000 centimeters cubed is equal to 1 decimeters cubed. Okay, so that means 1 decimeters cubed, how many grams is it? It's 692 grams. Okay, so now if you go back to the start, 1 gram gives you 47.8, so therefore how much does 692 grams give? It becomes simple now, isn't it? So now it's so 1 gram gives you that much, so it's 47.8 times by that many grams, 692 grams, which equals 33077 0.6 kilojoules. Okay, kilojoules, because that's in kilojoules. Okay, but remember, it says significant figures, appropriate number of significant figures. What's appropriate? Look at the question. 3 sig fig there, 3 sig fig there, 3 sig fig there, and therefore they want it in 3 sig fig. So the answer would be 3 sig fig is 3, 3. That's not 0. The next number is 7, so obviously you need to be careful. So that's 33100 kilojoules of energy given out. Only 2 marks, so it can't be that difficult. But if you've never sort of encountered this kind of a question before, it will put you off. So for example, when this question came up in the exam, a lot of students got it wrong. Why? Because they didn't know how to use the density. So for example, we often talk about density, but what you understand is, what does it mean? It just means that how many grams is 1 centimeters cubed. So break it down like that. So whenever they give you density, always have that in mind. Okay, can I break it down? So, 0.692 grams is 1 centimeters cubed. Can I use that information? Yeah, as we did in this one. So a lot of students got that, wrong in the exam. And the other, the other sort of place where they went wrong is significant figures. And that often happens, students often just ignore that. I don't know why. They think, they just put it in there because they've got too much time. Yeah, if they say, give this answer to the appropriate number of significant figures, then there's a mark associated with it. And if you ignore it, right, you will lose that mark. And considering it's only 2 marks, that's 50% of the marks gone. Okay, so now that you've encountered it, now that you come across it, hopefully next time a question like this comes up, you should be okay. I mean, Iso-octane, did I even need to know? Look, I didn't even pay attention to the actual IUPAC name. Yeah, I didn't even need to know it. Okay, so don't panic when you see these kind of questions. Go back to your basic principles. Start breaking things down. And of course, in the exam, if it was taking you too long to answer this question, put a star at the top of the page like this. Yeah, move on to the sort of next question, come back to it at the end. Okay, I hope that was helpful. It was a very short and sweet, but as I say, a student requested it, so it's only, an obligation. Yes, it's only fair that I actually go through it. Next week, I think it's going to be a 6-marker question. Yeah, so we'll see how it goes. And that's also a requested question, actually. Okay, any comments down below, please? And have a look at my other videos, if you're interested. I've got organic, physical, and inorganic as well. I'm particularly interested in any sort of non-physical help that I might be able to help you. Any questions, non-physical, so, inorganic or organic, that you might want to sort of need help on, or want help on. So put those kind of questions in the comment below, okay? And I'll see what I can do for you. Okay, I'll see you next Wednesday. Bye.